Welcome back, everyone. Italy is stepping into the quantum era with a national strategy focused on real-world implementation rather than long-term speculation. The country's national plan for quantum computing brings together research institutes, universities, and private industry to build practical systems for defense, medicine, logistics, and cryptography. Instead of relying only on imported technology, Italian scientists are developing quantum processors, control electronics, and error correction methods locally. This coordinated national approach aims to give Italy a secure foothold in the next wave of computing. Funding from the European Union and Italy's own recovery initiatives is being channeled into physical labs and prototype testing. This is no longer just theoretical research. It is active construction of Italy's place in quantum computing infrastructure. At the center of Italy's quantum computing effort is the development of superconducting qubits. These are tiny electrical circuits cooled to near absolute zero, where they behave according to quantum rules. Italian engineers are building chip prototypes using materials like niobium and aluminum, then cooling them inside dilution refrigerators. Each chip contains multiple qubits that can store information as quantum states. Special microwave pulses are used to control these states. The entire setup is kept in an ultra-cold vacuum chamber to avoid interference. This allows researchers to run simple algorithms and test how stable the qubits remain during operation. Italian teams are making significant progress in quantum control electronics. Traditional electronics cannot easily interface with quantum chips due to timing sensitivity and extremely low temperature requirements. Italian firms are developing custom control units that send precise signals into the cryogenic chamber to manipulate the qubits. These signals have to be synchronized to within billionths of a second and must avoid any thermal noise. The control system also reads the results of each quantum operation and sends it off to the main computer for processing. This interface layer is crucial if we want to scale any quantum computing platform. Error correction is, without a doubt, one of the hardest problems in quantum computing. Unlike classical computers, quantum systems are just so sensitive to environmental noise, which can easily disrupt calculations. Italy's research centers are working on both hardware and software methods to detect and fix these errors as they happen. One approach uses redundancy, where a single logical qubit is encoded across several physical qubits. Algorithms running on control electronics constantly check for mistakes and correct them in real time. These techniques are being tested on small quantum circuits as Italy moves toward fault-tolerant systems. Italy is also contributing to the design of quantum algorithms suited for real-world problems. Researchers at Italian universities are developing applications in molecular simulation, traffic optimization, and financial modeling. Quantum algorithms can simulate atomic interactions far more efficiently than classical ones, which is super useful for materials science and drug discovery. Italian software engineers write quantum code in languages like Qiskit and Cirq, then run the programs on simulators or early access hardware. This work bridges the gap between theory and practice and prepares Italy to apply quantum solutions in commercial sectors. Another active area of work is quantum annealing. Unlike gate-based quantum computing, quantum annealers are specialized devices that solve optimization problems using quantum energy states. Italy has invested in building and testing annealing machines that can solve logistics and scheduling challenges. These devices are easier to scale and maintain, compared to gate-based systems, making them suitable for near-term industrial applications. Italian developers are exploring how to use quantum annealing for energy distribution, factory scheduling, and transport planning in collaboration with national infrastructure providers. Quantum communication is an essential part of Italy's national plan. Italian scientists are testing quantum key distribution protocols over optical fiber networks between cities. These systems use particles of light to share encryption keys in a way that reveals any attempt to intercept them. Universities in Italy are coordinating with telecom providers to lay down test lines between Milan and Turin. These early experiments are helping to develop secure communication channels that could support quantum cloud services or even defense communication links. quantum-secure networks will probably be integrated with conventional infrastructure in the next few years. Cryogenics is another pillar of Italy's quantum development. Superconducting qubits and other quantum components need to be kept at extremely low temperatures. Italian companies are working on designing compact cryogenic systems that are not only more efficient, but also easier to maintain. These systems use either liquid helium or advanced closed-loop refrigeration methods to keep the hardware stable. Engineers are also working on automation features that let the entire cooling process be managed remotely. Improving cryogenic infrastructure is essential for deploying quantum systems outside research labs and into more industrial settings. Italy is building quantum test beds where hardware, software, and users can interact. These are physical labs equipped with experimental quantum processors, measurement devices, and support infrastructure. Researchers, students, and startup teams can use these test beds to run simulations, evaluate performance, and try new designs. The goal is to give hands-on access to real systems while fostering collaboration across different sectors. Public research institutions are partnering with commercial companies to expand the reach of these facilities and offer services to other European countries that do not yet have similar resources. Italy is working on integration between classical and quantum systems. Most quantum computers will not operate independently. They will act as accelerators, handling specific parts of a problem, while classical computers manage the rest. Italian engineers are developing software tools that split workloads between the two systems and ensure data flows smoothly between them. This hybrid architecture allows existing systems to benefit from quantum speedups without needing to be replaced. It also helps transition businesses from conventional computing to quantum-enhanced processing in a gradual and practical way. In the longer term, Italy may develop distributed quantum computing networks that combine multiple quantum processors across different cities into a single coordinated system. This would involve linking quantum computers through secure quantum communication channels and managing workloads dynamically based on system availability and task type. Such a network could allow researchers and industries to access shared quantum resources, much like today's cloud computing. Italy's strong foundation in both fiber optics and network engineering would support this evolution, making the country a regional hub for quantum services accessible across Europe and potentially beyond. Looking even further ahead, Italian researchers may begin designing quantum systems that interact with biological processes. This could involve quantum sensors used for brain imaging, protein structure analysis, or advanced diagnostics. By applying quantum technology to medical and life sciences, Italy could lead new interdisciplinary fields that merge quantum mechanics with biology. These systems might enable real-time imaging at the cellular level, or detect diseases earlier than current methods allow. With its strong academic infrastructure and history of medical research, Italy would be well positioned to pioneer such advanced applications. Italy's strategy stands out because it focuses on application as well as theory. With working labs in Florence, Milan, and Rome already testing quantum processors and algorithms, Italy is moving beyond conferences and toward deployment. Quantum cloud services will soon allow Italian firms to test new solutions for chemistry, logistics, and finance using early access systems. At the same time, new degrees in quantum engineering are training a local talent pool ready for this shift. If the national plan succeeds, Italy will not only use quantum computers, it will design, build, and export them. Thank you very much for watching. Please like and subscribe.